Good viewers. So basically today's GFG POTD we have a problem, Palindrome binary, and it is a easy level problem. And as the problem statement is given is check if the binary representation of number is Palindrome or not. So basically the given problem here in example 1, here our n is like equal to 17, and here output will be like 1. So we know very well after conversion of 17 in binary form we get the digit like 10001. So if we are going to check whether the given binary digit number is palindrome or not, so in that case if it is like palindrome, then in that case we have to return 1, else we have to return 0. Now similarly, if I'm talking about the second example here, so here we have n is equal to 16, and if we are going to convert my decimal number 16 to a binary number, so here we will look at as like 1 then 4 times 0, and by looking at this number we can say that it is not a palindrome number. So here our output will like 0, and here our task is as like also mentioned, you don't need to read input or print anything. Your task is to complete the functions is palindrome, which takes an integer n as a input parameter and returns 1 if the binary number equivalent of n is palindrome. Here we need to solve this problem with an expected time complexity of order of n, order of log n, and expected space complexity of order of log n. And this problem is like as important as it is like in multiple product-based companies like Amazon, Microsoft, and Adobe. And here constant is like also given where n is like greater than equal to 1 and less than equal to 10 for 18, and it is completely based on mathematics and algorithm. So let's try to solve this problem here. So what is my approach to solve the given problem here? Here first of all I'm going to break down the problem here. So here first of all I need to check the given decimal number which I have to convert into the binary number and check whether the given binary digit number is a palindrome number or not. So in that case what we'll do, so in my step first I will do first of all conversion of decimal number to binary number. So if we are going to do these things, so what I can do, so I know very well about how we have to convert any decimal number to binary number. So for that case we have to first of all get an answer variable which we have to initialize it with 0, or we have to simply declare it. Then after that we have also initializing it with one power, which we have to initialize it with 1, and then after that we have to traverse inside the number n. Okay, so here we can say if n is like not equal to, if n is like greater than 0, so in that case we have to do what, we have to traverse. Okay, so we have to check for each digit. So here what we will do, yeah, first of all we have to again initialize one more variable which is the last digit for getting the last bit, or we can simply say that bit, it is the last bit. Okay, so here we will do what, n modulus, if we have to convert decimal number to a binary number, so here we have to take the modulus to 2, those numbers which we have to convert, from that number we have to take the modulus. Like here we have to convert to binary numbers, so in that case we have to take modulus from 2. Okay, then after that we have to do we have to store our output inside the answer variable. So answer plus is equal to whatever is our last digit. Okay, we have to just keep multiplying with power. Okay, and we have to just take the power from our original source, which is a decimal number, that means 10. So here we have to take power multiplied by equal to 10, and then we have to just continuously divide my number to the binary number form. So here we have to divide it by 2. Okay, those number which we want to convert. Okay, so here if I am going to return about my answer, so in that case here I get binary number for the given decimal. Alright, let me try to compile and run. So yeah, as we can see here, for the given input 17 we are actually getting the correct output like 10001, but here our expected output is like 1, because here we need to also check for the palindrome that whether the given number is palindrome or not. So here we know very well our answer is like an integer form, and if we have to check the palindrome, so we require some kind of arrays or like a string format things, so that we can check it easily. we can't able to change, we can't able to check directly the given number is string or not, or sorry, palindrome or not. So in that case, what we'll do, um, I'm just going to simply check, or just simply going to convert this all number to the string format. Okay, so here I'm going to follow the second approach, which is string binary is equal to, and I am initializing with empty string. Then after that, while n is greater than 0, then here I have to just simply convert. Okay, I just don't have to use these two lines, and I can just simply convert the given decimal number to the binary number directly. And how I can do those things? Let's say int last digit is equal to n mod plus 2. Okay, and here I don't have to even use about last digit. Here I can just simply use a binary plus is equal to n modulus 2 plus here we just simply use 0. Okay, by using these things actually I'm getting what here, I'm getting the decimal value to the binary value. Now after taking the divisor of n continuously by 2, we actually getting our final value. So again, if I'm going to like return my binary number here, so in the string format, so again I'm getting what here, in this time I'm getting error because it is integer type and I'm returning a string type number. Okay, so let's say if I'm going to compile and run. Okay, so yeah, it is returning an error. So now what I will do here, I'm going to now my final value is like in the form of integer, sorry, string format. So now I can check here in my step 2. Now I can simply check whether the given number is string or not, is palindrome or not. So for that, what we'll do here again, we have to create, let's say int I is equal to, I'm to take I'm going to have to initialize with 0, and let's say int j is equal to whatever is the size of binary dot size minus 1. Okay, that means I'm going to check from both forward and backward. Okay, so now again here I have to just simply use by using while loop, like while I is like less than j, then in that case you can just simply check if binary of I, if it is like not equal to binary of j, then in that case we have to return 0. Okay, as per the question, and then here we do I plus plus and then j minus minus, else we have to return 1 if it is like palindrome. So let's try to compile and run again. Okay, int binary. Okay, one more thing here, I'm done wrong here, I don't have to use the data type. Now again, let's try to compile and run. So yeah, here compilation is complete. Let's try to submit it. So yeah, it's submitted. So yeah, that's it for today. Thanks for watching.